We have given function when domain of our function will be all real numbers. Why? Because we have the power, we have subtraction, addition, multiplication. We can add, subtract, multiply every real number. That's why we have the domain for our function. Why? All real numbers. Next, to find maximum and minimum, we need to find critical values. To find critical values, we need to find the first derivative and set the first derivative equals 0. So, let's find the first derivative first. Y prime is equal 3x squared minus 6 times 2x. Derivative of constants is 0, so we don't have to write. So this is equal 3x squared minus 12x. This is our first derivative. Next, we have to check when first derivative is equal to 0. If and only if we have 3x squared minus 12x is equal to 0. We have quadratic equation. To solve this, we will factorize 3x, so it will be x minus 4 in parentheses. So this is equal 0 when 3x equals 0 or x minus 4 is equal 0. So we have first root x equals 0 and second x equals 4. These x's are our critical values. Now, to find if we have maximum or minimum, I think the easiest way is to draw the graph of our derivative function, because we have quadratic function. So the graph is parabola. The parabola is open up because we have positive coefficient before x squared. We have 0, 4 roots open up. And we see when we on the right side of 4, we have positive values because this part of our graph is above x-axis. This part is under, so has negative values. And this part is above, so it means has positive values. So when we change sign from positive to negative, we have minimum. When we change sign from negative to positive, we have maximum. Now we have to just calculate these points. We have x's, so we can find the y. So y of 0 is equal, we have to replace in our function x's by 0. So we have 0 to third power minus 6 times 0 to second plus 14. So this is equal 14. We have first point 0, 14. This is our maximum. Next, we need to find a minimum point. So we have y of 4. It means we have to replace our x's by 4. So it's 4 to third power minus 6 times 4 to second power plus 14. This is equal. So we have 4 to power third is 64 minus 6 times 4 to second power is 16. 6 times 16 is 96 plus 14. This is equal negative 18. So we have our minimum point is 4, negative 18. We have in this point minimum. Now we have to check if our function has inflection points. So we need to find the second derivative first. So when we have to find the second derivative, it means we have to find the derivative of our first derivative. So it is 3 times 2x minus 12. So y bis is equal 6x minus 12. Now we have to set our second derivative equal 0. this is equal 0 if and only if 6x minus 12 is equal 0. So we have to solve this linear equation. We have 6x equals 12, so x is equals 2. So we can have inflection point. To be sure that we have inflection point, we have to check if the second derivative changes sign a small distance to either side of x equals 2. To do this, the easiest way, in my opinion, is to draw the graph of our second derivative function. So we have x number line, and we don't need y-axis, just we have to sketch this graph. This coefficient before x is positive, so it means our function is increasing, and we have the roots 2. So just draw this graph. This is y bis 6x minus 12. On this graph we have graph our function y prime equals 3x squared minus 12x. When we have to find maximum and minimum, we draw the graph of first derivative function. And when we have to check inflection points, we draw the graph of the second derivative function. So we have this, and we see when we are close to 2, from the right side we have positive values because this part is above x-axis and this part is under, so has negative values. So we at 2 we change the sign from positive to negative values. So it means we have inflection point. So we have to just calculate this. Y of 2 is equal, we have to replace our x's now by 2. So we have 2 to third power minus 6 times 2 to second power plus 14. This is equal 8 minus 6 times 4 is 24 plus 14. This is equal minus 2. So we have inflection point 2, negative 2. This is our inflection point. This is my solution.